So this is the 2014 Junior Cert Ordinary Level Paper 2, and we're looking at question number 6. The question reads, Part 1, plot the points A, which is 3, 1, B, which is 0, 4, and C, which is -2, -1 on the grid below. Join the points to form a triangle. So we're going to plot the point A first. The point A is 3, 1. So from the origin we're going to go to 3 on the x-axis and up to 1 on the y-axis. Then point B is 0, 4, so from the origin we're going to go 0 on the x-axis, which is where we are already, and then up to 4 on the y-axis. And finally, I'm just going to label them, that's A, that's B, and finally C, which is over to -2 on the x-axis and down to -1 on the y-axis. So there's our point C. So now I'm just going to join the points to form a triangle. So from C I'm going to go over to A. From B I'm going to go down to A. And also from B I'm going to go down to C. There's my triangle. Part 2. By calculating the length of AC, these straight brackets mean the length of that line segment AC, and the length of BC, show that the length of AC is equal to the length of BC. So we're trying to find the distance between 2 points here. Now we have a formula in our tables book, which is down here. This is the distance formula in our tables book. So we're just going to use that to calculate the distance between the points. So the point A is 3, 1, and the point C is -2, -1. So A is 3, 1. And the point C is -2, -1. And then over here we're going to do the length between B and C. So the point B was 0, 4, and the point C was -2, -1. So the point B, 0, 4. And again the point C was -2, -1. So we're going to find the distance between these 2 points and then the distance between these 2 points and show that they are equal. Okay, so what we need to do then to use these points here in the formula, we need to label these points. So one of the points you're going to call x1, y1. It does not matter which point you call that. And the other point you're going to label it x2, y2. So I'm just going to color code this here for you. So you can see you're going to plug these values then in here. So you're going to have x1, which will be in here. And again up here, that's going to be our x1 value here. Then you're going to have your y1 value in green. The y1 value for this over here would be the 4. Y1 there. And we've got the x2 value here. And when we're doing it over here, it's going to be that one. And finally, the y1 value. It's going to be the y2 value, sorry, which will be here. Okay, so to find the distance here, it's going to be the square root of x2, which is the blue number highlighted, which is -2, minus our x1, and our x1 is 3. And that's going to be squared, plus our y2 value, which will be the -1, subtract the y1 value in green, which will be 1. And then you're just going to put all of this here into your calculator, exactly as it is there. And when you press equals, the value you get is √29. So there's no need to write it as a decimal, just leave it in surd form like this. So that's the length of the line AC. So now we're going to do BC. So again, the same formula. And we've already got it color coded. We just forgot to color code that last one. So we're going to have the blue blue minus the yellow, so that's minus 2 minus 0 squared, plus, in brackets, the purple minus the green, that's minus 1 minus 4. And then again, when you put all this into your calculator, you're going to see that you get the same answer. You get root 29. So now we've shown that the length of AC is equal to the length of BC. Part 3 says, what type of triangle is the triangle ABC? Well, we've just shown that two of the sides are the same length. So if two sides are the same length, then it's going to be an isosceles triangle. Isosceles. Part 4, D is the midpoint of the line segment AB. These brackets here, square brackets, are the symbol for a line segment. Find the coordinates of D. So we're looking for the coordinates of the D. So the midpoint formula, which is this one over here, again we get this from the tables book. The midpoint, we're going to find the midpoint of AB. So again, our A point was 3, 1, and then B was 0, 4. So we're going to just plug these numbers in to this formula. And again, I'm just going to color code this for you here. So, well, let's label the points first. So we're going to call this x1, y1, and then we're going to call B x2, y2. So color coding that, we've got x1 will be the number 3 in there. And have x2, this time is going to be green, that's going to go in there. Then y1, which will be the number 1, will go there. And y2, which will be the number 4, will go here. So when we plug these values into our midpoint formula, we get x1, which is 3 plus the yellow plus the green, so 3 plus 0, all divided by 2, comma, the blue plus the purple, so that's 1 plus 4, all divided by 2, comma, and then we're just going to simplify that. Well, 3 plus 0 is 3, so that's just going to be 3 over 2 is the first coordinate, and 1 plus 4 is 5, so 5 over 2 is the second coordinate. Now you could write that as decimals also, if you wanted, but this answer here will get you full marks. If you do write it as a decimal, it's going to be 1.5, comma, 2.5. But both of those answers would get you full marks. Part 4 then says to draw the line CD on the diagram. So we're going to draw a line from C to D. So D, this is the point D here, 1.5, comma 2.5. So we're going to go back here and we're going to plot D. So we go over to 1.5 and up to 2.5. That's our point D there. And we're asked to draw a line CD. So from C, we're going to draw a line up here to D. That's our line CD. Okay, and finally part 6 says, show that the triangles ADC and triangle BDC are congruent. Use SSS or SAS. Well, congruent, that just means identical. All the corresponding sides are the same length and the corresponding angles are the same size. So if we're to prove congruency, we can prove SSS, which means that the side, in other words, the three sides are the same on both triangles, same length. Or we can use side, angle, side, where we prove that a side, another side, and the angle between them are the same length. So, in order to prove that, we're going to go back and have a look at our diagram here. So the triangles we're talking about are ADC, Just to visualize this, the triangle ADC is this one here, ADC, and then the other triangle is the triangle BDC, which is the one in green, BDC. There's the green one. So they're the two triangles, and we're trying to prove they're congruent. So we can see here, well, they both, the CD, the line CD is in both triangles, so that's one side that's in both. So we can say that the length of CD is equal to the length of CD. And we just say, give our reason that's in both triangles. So that's one side done. Now we also know that A to D is going to be equal to D to B, because D is the midpoint of AB. So we can say that BD is equal to DA. D is midpoint of AB. So now we've got a side, another side, and if we go back to the diagram now, we can see, well, from part 2 of our question, we showed that AC was equal to BC. So AC is this side here, and BC is this side there. So that's our final thing to show, that the length of the line AC is equal to the length of the line BC. We did that in part 2. And you could say they're both root 29. So we have used side, side, side to prove congruency, or that the triangle ADC, so you just say therefore triangle ADC and triangle BDC are congruent, because we have proved side, side, side for them. And that's the end of the question.